Hello and welcome to this Edexcel walkthrough for my higher Paper 2 practice paper. In order to create this paper, I've looked at all of the topics that came up in Paper 1 and compared them to topics that come up in past papers, so hopefully the topics selected are relatively likely to appear. I'd encourage you to head over to my website, firstclassmaths.com, and if you click on the exam papers page you'll see this, and you can find a document there which lists all of the topics along with their importance for your Paper 2 revision. So let's begin with question 1. Here we need to expand and simplify some brackets. To do this, we're going to multiply all of the terms in the first bracket by all of the terms in the second bracket. So we'll begin with x times x, which gives you x squared. Then move on to x times negative 6, which is minus 6x. Negative 3 times x, minus 3x. And finally, negative 3 times negative 6, which is a positive 18. Here we just need to simplify. We've got a negative 6x, a negative 3x. That'll give you negative 9x. So the final answer to this question is x squared subtract 9x plus 18. For question 2, we've got a number in standard form and we need to write this as an ordinary number. So let's take the number 7.2, and since it's multiplied by 10 to the power negative 4, that's like dividing by 10 4 times. So let's divide by 10 once. That will give you 0.72 a second time, a third time, and a fourth time. So we end up with the number 0.00072. For the second part of the question, we need to take this number, 620,400, and write it in standard form. To write a number in standard form, you first of all need a number that's between 1 and 10. So for this one, we need to go for 6.204, and then we need to consider what power of 10 we multiply it by. So let's put the decimal point in between the 6 and the 2, and see how many times we need to multiply this by 10 to get back to the number 620,400. So it's 1 time, 2 times, 3 times, 4 times, 5 times. So it'll be 10 to the power 5. For this next question, you can just type all of that into your calculator because it's a calculated paper. Your calculator will probably show you the answer, 9,600,000. The question says to give our answer in standard form, so we'll do the same process as we did in the last one. It's going to be 9.6 for our number between 1 and 10. And then we need to work out the power of 10. So let's place that decimal point between the 9 and the 6. And then it's 1, 2, 3, 4, 5, 6 times that we multiply by 10. So it's times 10 to the power 6. For the first part of this question, we need to take all of these x values here and substitute them into this formula here to get some y values. You need to be particularly careful with the negative numbers and make sure you put them in brackets. So let's start with x equals negative 4. So we're just going to copy out x squared plus 2x minus 5, but replace the x's with negative 4. Remembering that bracket. So instead of x squared, it's negative 4 squared. Then it's plus 2x, so it's plus 2 lots of negative 4, and then take away 5. Now since this is paper 2, you can just stick that straight into a calculator, and that'll give you the answer 3. So when x is negative 4, y is 3. Then we can move on to when x is negative 3, so it's negative 3 squared plus 2 lots of negative 3, take away 5, again straight into your calculator, and that gives you negative 2. Now in the question they've already done negative 2 and negative 1, so we'll move on to 0. So it's 0 squared plus 2 lots of 0, take away 5, which is negative 5. Let's put that into the table, and finally, when x is 1, 1 squared plus 2 lots of 1, take away 5, is negative 2. So that completes the table. For part B, we need to draw the graph. So what we're going to do is take each of the pairs of values and plot them as coordinates. Let's start with negative 4, 3. That point goes here. Then negative 3, negative 2. That goes here. Negative 2, negative 5. That goes here. Negative 1, negative 6 goes here, 0, negative 5 goes here, 1, negative 2, and finally 2, 3. So if you've done this correctly, you'll end up with points that form this kind of U shape here. We need to join those up with a smooth curve, not straight line, so something that looks like this. For the final part of the question, we need to use the graph to find estimates to this equation. Now notice the first part of the equation, the x squared plus 2x minus 5, matches the graph we just drew. The right hand side though just says 1. So since we drew y equals x squared plus 2x minus 5, we just need to draw y equals 1 and find where they cross. Y equals 1 is a horizontal line that goes through 1 on the y-axis, so something like this, and you can see they cross in 2 places. We just need to read off the x coordinates of those since we're solving an equation in x. So if we draw some lines down to the x-axis, you can see the left one here, I'd say that's about negative 3.6, and the right one probably positive 1.6. You'd be allowed to be one decimal place out on either of those. For this question, we're looking for the transformation that maps rhombus A onto rhombus B. So I can tell since the shape has been turned round, this one must be a rotation. So what we'll need to do is take some tracing paper, draw over the shape, and then we need to try and find the centre of rotation. Now in order to do this, you'll want to place your pen somewhere on the grid and turn your tracing paper and see if the shape A matches onto shape B. This sometimes takes a few tries, and with a little practice you'll get better at this. It turns out for this one, the point is here at negative 3, 3. So if I place my pen on that point and turn the tracing paper, you can see it does match perfectly onto shape B. We turn that tracing paper in a clockwise direction for 1/4 of a turn, so 90 degrees. So to write down this transformation, we would write it's a rotation. We went 90 degrees clockwise, and then we state the point we rotated it about, which was negative 3, 3. Now there is actually another possible answer for this depending on where you place your point. You could also have got all the marks for saying it's a rotation, 90 degrees anti-clockwise, but about this point, 0, negative 2. For the second part of this question, we're going to enlarge the rhombus A by scale factor 2 with a centre of enlargement 1, 2. So to start this off, we're going to mark on the centre of enlargement, that's at 1, 2, that's here. That happens to actually be on the shape itself. Next, we're going to go around each of the vertices of the shape and consider where they'll be enlarged to. So let's start with the one at the top here. To work out where it needs to go, we need to work out how you get from the red centre of enlargement to this green cross. And in this case, it's just up 1 square. So we're going to double that, so rather than going up 1 square, we're just going to go up 2 squares. So it ends up here. Then we'll do this one on the left. So to get from the red centre of enlargement to this blue cross, we go left 2 squares. So actually we'll double that, it should be left 4 squares. Then the one at the bottom here, so to get from the red one to the orange one we go down 1 square, so we actually need to make it double that, down 2 squares. And then for the one on the right, that's this purple one here, from the red one to the purple one is to the right 2 squares, so we double that, and it's to the right 4 squares. You can then join up all of these crosses and you'll see the final rhombus. For this question, we need to write an error interval for the number 140 grams, rounded to the nearest gram. To do this, I like to draw out a number line. I'll place the number from the question in the centre, so that's 140 grams, and then we need to consider what goes at either end. Since this was to the nearest gram, we're just going to go 1 gram below and 1 gram above. So 1 gram below 140 is 139, and 1 gram above is 141. Now the error interval will be formed from the numbers that are halfway in between these, so this highlighted bit here. Halfway in between 139 and 140 would be 139.5, and halfway in between 140 and 141 would be 140.5. So those are the upper and lower bounds for the error interval, so it's 139.5 and 140.5. In this question we've been told the second term of a sequence is 18, and also the ratio of the second term to the 11th term is 2 to 7. So let's write that ratio down. We've got the second term to the 11th term in the ratio 2 to 7, but we know what the second term is, that's 18, so we'll write that underneath the 2. Next we need to consider what we multiply 2 by to get to 18, which is times by 9. This means we can just multiply the 7 by 9 as well, and this will give you the 11th term. So 7 times 9, 63. Then in the question we're asked to find an expression for the nth term of the sequence. So in this sequence we know the second and the 11th term. So we don't know the first term, we know the second one, that's 18, we also don't know the third term all the way to the 10th term, but we do know the 11th term is 63. So to get from 18 to 63 here, we need to add on 45. But to get from the second term all the way to the 11th term, we must have jumped 9 terms. So if we do 45 divided by 9, we know that each of these single jumps here is a 5. So to get from one term to the next term in this sequence, you add on 5. We can now go back to the first term by subtracting 5, so 18 take away 5 is going to give you 13. We're now ready to find the nth term of the sequence, so since it goes up in 5s it must be a 5n sequence, but it doesn't start at the number 5, it starts at 13, so we need to add on 8 as well. Since 5 add 8 is 13, and that gets you the first term. So the nth term is 5n plus 8. For this question, we need to find the perimeter of this parallelogram. To find the perimeter, we'll need to know the lengths of all of the sides. Now we can see the side DC on the bottom, that's 12, which means the side at the top, AB, must also be 12. So we're just missing AD and BC. Let's focus on this triangle here, DBC. We can see from the right angle in the question that this triangle is a right angled triangle. So let's label the sides. This 12 here will be the hypotenuse. BC on the right hand side will be the adjacent, and DB would be the opposite. Using this, we can write down that cos of 76 must be the adjacent, which we don't know, so we'll just call that A, divided by the hypotenuse, which we do know, that's 12. So we can rearrange this. If we multiply by 12 on both sides, we find the adjacent is equal to 12 cos 76. And that's one of the sides we were looking for. If you type this into your calculator, you'll find that the adjacent is equal to 2.903, and so on. So that's the length of BC up here, but it's also the length of AD over here. So to find the perimeter, we just need to add all of these up. So we've got 12, add another 12, add the 2.903, and the other one, and if you add all of those up, and then round to one decimal place like it asked for in the question, you'll get 29.8. For this question, we need to complete the table. You'll see all three of these probabilities here must add up to 1. So if we start with 1 take away 0.58, we get 0.42, which means the probability for blue and green needs to add up to 0.42. Now we're told this fact in the question, the probability of selecting a blue counter is equal to 2/5 of the probability of selecting a green. So let's call the probability of selecting a green x, then the probability of a blue is 2/5 of that, so we can just write 2/5 x. We said a moment ago that both of those probabilities need to add to make 0.42. So we've got 2/5 x, add 1x, is 0.42. If you add 2/5 x to 1 whole x, you've actually got 7/5 x. And this equals 0.42. And you can solve this just by timesing by 5 on both sides, then dividing by 7, and this will give you x equals 0.3. So we find that x is 0.3, so we've got the probability for green. And then if we do 2/5 of 0.3, again, just use your calculator here, type 2/5 times 0.3, that'll give you 0.12. For part B of the question, it says there are 87 red counters, and we need to find the total number of counters in the bag. So we know the probability of selecting a red counter, that's 0.58, or 58%, so these 87 counters represent 58%. Now we want to know all of the counters in the bag, you could think of that as 100%. So if we divide both sides of this by 58, we'll go down to 1%. Divide 87 by 58, you get 1.5, and that's 1%. You might think that sounds a little bit weird because you can't have half of a counter, but it doesn't matter because we're now going to multiply this by 100. If you multiply both sides by 100, you find that 150 counters is the same as 100%. So that's all of the counters in the bag, so the answer must be 150 counters. In this question, we've got Bradley who's going to invest £7,000 at 8.5% compound interest. And we're told he also leaves it in for 3 years at first. So let's work out how much would be in the account after 3 years. So we've got £7,000. The interest rate is 8.5%, so that corresponds to a multiplier of 1.085. And since he's going to leave it in there for 3 years, we write this to the power 3. If you type that into your calculator, it'll give you this value here. The question then says that after 3 years he withdraws half of the money. So if we divide this by 2, we'll find out how much is left in the account, which is this much. He's then going to leave this money in the account for a further 2 years. So if we take this amount, the interest rate is going to be the same, so we still times by 1.085, but for 2 more years this time, so the power 2 instead of the power 3. Type this into your calculator and you'll get this as the answer. And it says how much is left in the account after 5 years, which is this amount here, so £5,262.80. For the first part of this question, we're going to need to factorise the top of the fraction. To do this, we can factorise out 2x since it's a common factor of both terms, and then we need a bracket. Now inside that bracket, the first term will be x, since 2x times x is 2x squared. And then we need to work out what we multiply 2x by to get negative 6x, and that's negative 3. Then we've got over x minus 3 on the bottom. You can see we've got x minus 3 on the top and the bottom here, so we can cancel that factor, and you're just left with 2x, which is the answer to the question. For the next part of this question, we're going to focus on what's inside the brackets first. So if you do 8 divided by 0.5, you'll get 16. You can do that on your calculator if you need to, remember. And then we've got a to the 48 divided by a to the 4. When you divide here, you subtract the powers, so 48 take away 4 is 44, so it's a to the power 44. So inside the bracket would be 16 a to the power 44, and this is all raised to the power 1/4. A power of 1/4 means you need to do the fourth root. So we can do the fourth root of 16, or on your calculator you could type in 16 to the power 1/4 if you want, and that will give you 2. And then we need to do the fourth root of a to the 44. Now this is easier if you just multiply 1/4 and 44. A quarter of 44 is 11, so it's a to the power 11. In this question, we've got a farmer who's collecting potatoes. I don't know why, but Edexcel seem to be quite obsessed with potatoes, so this is definitely coming up. For the first part of the question, we need to use the graph to find an estimate of the median mass of the potatoes. So there were 600 potatoes altogether, so the one in the middle, which is the median potato, will be somewhere around 300. So if we go to 300 on the cumulative frequency, read across until we hit this graph, and then go straight down from there, you can read off this value is about 240 grams. For the second part of the question, we're told the farmer only sells potatoes that are between 180 and 320 grams. We need to work out the percentage of the potatoes that can be sold. So if we start with 180 grams, and go up to the graph, and then read across, you'll see the cumulative frequency here is 120. Let's do the same for 320, so 320 up, then across, reads off at about 560. So the potatoes that can be sold are between 180 and 320. So we need to know how many potatoes are in between 560 and 120. So we can just subtract those numbers. 560 take 120 is 440, so there are 440 good potatoes that can be sold. To work this out as a percentage, we just do 440 divided by the total number of potatoes, which is 600, and then times that by 100. Remember, just use your calculator here, and this will give you 73.3%. In this question, we've been told the sum of 4 consecutive integers is 1478. Integers are just whole numbers, and the word consecutive means they're one after the other. We need to work out the greatest of these 4 numbers. So let's call the first of these numbers n. Since they're consecutive, the next one would be n plus 1 since it's one more. The one after this will be n plus 2, and then n plus 3. Now if we've been told the sum of the numbers, we need to add all of these together. So n plus n plus 1 plus n plus 2 plus n plus 3. And this needs to make the total 1478. We can now simplify the left-hand side. N plus n plus n plus n is 4n, and 1 plus 2 plus 3 is 6. And this equals 1478. Now we just have an equation to solve, so we can take 6 from both sides. On the left that gives you 4n, and on the right 1472. Then divide both sides by 4, you get n equals 368. So we found the value of n, but remember that was the first term. We've been asked for the greatest of these 4 numbers, so that's actually the number n plus 3. So if we do 368 plus 3, you get 371. In this question, we've been told the probability that at least one of the counters is yellow is 0.91. Now if this is the probability that at least one of the counters was yellow, the opposite situation would be if no counters were yellow. So the probability of no counters being yellow is 1 take away 0.91, which is 0.09. Now if you think about it, if we had no yellow counters, they must both be blue. So the probability that both counters were blue is 0.09. Now this means the probability of selecting a blue first and the probability of selecting a blue second. Now each of the individual probabilities for selecting a blue counter will be the same each time since the counter is returned to the bag. This means we can just square root 0.09 and find the probability of a blue is 0.3. If you find it easier to understand, 0.3 times 0.3 is 0.09. So we now need to work out the probability that exactly one of the counters is yellow. To select exactly one being yellow, we could select a blue first, followed by a yellow. The probability of this will be the probability of a blue, which is 0.3, times the probability of a yellow, which we can now work out by doing 1 take away 0.3, which is 0.7. Timesing these together will give you 0.21. But we could also select a yellow first, so it's the probability of a yellow followed by a blue, which is 0.7 times 0.3, which is also 0.21. So if we add those probabilities together, we'll find the probability that exactly one was yellow, and that's 0.42. In this question, we've been given a histogram and we've been asked to criticise it. We need to write down the mistakes that Sean has made. So first of all, if you have a look at this axis here, you can see Sean's labelled that as frequency. And if you look at the table, you can see he's actually plotted the frequencies here for the heights of the bars. For a histogram, you should know that you shouldn't plot frequency, but frequency density. So we could write that Sean has plotted the frequency rather than frequency density. For the second part, we're going to look at the other axis, this one along the bottom. Now each of the bars here appears to be the same width. But if you look carefully, this first bar here goes from 0 to 30, so that's a width of 30. But the next one goes from 30 to 50, that's a width of 20. The next one's also 20. And the final one goes from 70 to 80, and that's a width of 10. So Sean hasn't done his scale right on the bottom either. So we could write something like, Sean's scale for the mass is not consistent. For this question, we've been given lots of different ratios. It will be easier if we can write these as one single ratio. So the ratios we have, A to B is 3 to 5, B to C is 1 to 2, and C to D is 5 to 6. To write these as a single ratio, we need to match up the numbers for the letters that appear in both ratios. So the first one here has A to B, and the second one has B to C. So in the first ratio, the B is 5, but in the second ratio, the B is 1. So we need those to match. So I'm just going to multiply the middle ratio here by 5, and rather than 1 to 2, that will now be 5 to 10. But you can see the numbers for B's in the first and the second ratio now match. I've got 3 to 5 and 5 to 10, and both of the B values there are 5. Now if we do the same thing with the final ratio, so if you look at the second ratio and the final ratio, you can see they both have a C in them. So we need to make the numbers where the C is match. So we've got 5 to 10 for the middle one and 5 to 6 for the last one. But we need that 10 and that 5 to match, so we could double the last one as well. So if you double 5 to 6, you get 10 to 12, and now you can see the numbers for the C's are matching. So if we take these ratios here, you can see that A would be 3, B would be 5 in both of them, C would be 10 in both of them, and then D would be 12. So the ratio for A to B to C to D is 3 to 5 to 10 to 12. Now, how does this help us with the question? So there are 4 angles in this question. We'll write out the ratio and also create a total column. So the ratio was 3 to 5 to 10 to 12. And if we add up all of those parts, 3 add 5 add 10 add 12, you get 30. Now since this shape is a quadrilateral, its total must be 360 degrees, so we'll put that underneath the total column. And then work out what we multiply by 30 to get to 360, which is 12. This means to find out the angles, all we need to do is multiply the parts of the ratio by 12. 3 12s are 36, 5 12s are 60, 10 12s are 120, and 12 12s are 144. So those are the sizes of all of the angles. Now we need to check that it's a cyclic quadrilateral. In a cyclic quadrilateral, the opposite angles add up to 180. If you look at the diagram, you can see that A is opposite D, so let's add A, which is 36, to D, which is 144, and there we go, it's 180. Let's do the same with C and B. So if you add B to C, you get 60 plus 120, which is also 180. And then we should put a concluding statement that shows we know this fact, so opposite angles add up to 180, so this must be a cyclic quadrilateral. To start this question, I'm going to draw a line connecting D and B. Since this shape is a square, we know all of its sides are 12, so we've got 12 on the bottom, on the top, and also on the right. We're now going to use Pythagoras on the triangle DCB to try and help us work out the length of DB. So we would do DB squared equals 12 squared plus 12 squared. If you do 12 squared plus 12 squared, you get 288. And then to find DB, we would square root this, so DB equals the square root of 288. Let's add this onto our diagram. Now this line here from D to P is the radius of the circle, which is also 12. Now this will help us find out the length of this smaller radius here from P to B. To do this, we take the whole length of the line DB, which is square root 288, and subtract the length of the blue line, which is 12. So the length of the line from P to B is square root 288, take away 12. Now we've been tasked with finding the area of this sector, So we'll use the formula for the area of a circle, which is pi, times the radius, which we now know is from P to B, which is square root 288 take away 12, but we need to square that since it's pi r squared. If you type this into your calculator, you'll get this number here. But since this is 1/4 of a circle, we'll need to divide this by 4, which gives you this answer, and we've been asked to round it to 1 decimal place, so 19.4. We're going to start this question by looking at the surface areas of the two pieces. So we're given those in the table 12 and 30.72. If we do 30.72 divided by 12, we get the answer 2.56. This tells us how many times the area of the larger piece is bigger than the area of the smaller piece, so we could call out the area scale factor. Now if you've got an area scale factor, you can find out the length scale factor by square rooting this. So the square root of 2.56 is 1.6. So that's the length scale factor. You can then turn that into a volume scale factor by cubing it. So 1.6 cubed gives you 4.096, which is the scale factor for the volumes. Next we're going to try and work out the volume of the small piece. Hidden in the question, we're told the density of the small piece is 0.8 grams per centimetre cubed, and in the table we're told the mass of the small piece is 4 grams. So you can use the formula for density equals mass divided by volume. So volume equals mass divided by density. So for the small piece, the volume is the mass, which is 4 grams, divided by its density, 0.8, and 4 divided by 0.8 is 5. So we know the volume of the small shape is 5 centimeters cubed. Now earlier on we found the volume scale factor. That was 4.096. So we can work out the volume of the larger piece by doing the volume of the smaller one, which was 5, times by the volume scale factor, 4.096. This gives you the larger piece's volume at 20.48. Now we've been asked to find out the density of the large piece, and we need to give the answer to 3 significant figures. We'll go back to that density formula again. It's mass divided by volume. We know the mass, that's 10 grams for the larger piece, and we've just worked out its volume at 20.48. So the density equals the mass, which is 10 divided by the volume, 20.48, and remember round it to 3 significant figures, is 0.488. We're going to start this question by looking at the equation we're given for the circle x squared plus y squared equals 16. You should already know the equation of a circle is x squared plus y squared equals r squared. So r squared equals 16, in which case the radius of this circle is 4. So we can add on the radius, which goes from O to A, which is 4. You should also know that when a radius meets a tangent, it makes a 90-degree angle, so we can add this to the diagram as well. And next we're going to try and work out the length from A to B. Since this is a right-angled triangle, we can use trigonometry again. This side here at the bottom from O to B would be the hypotenuse. From O to A would be the adjacent, and from A to B would be the opposite. So we can work out the opposite using tan. Tan of 80 must be the opposite, divided by the adjacent, which we know is 4. You can rearrange this by multiplying both sides by 4 to give you the opposite equals 4 times tan 80. Now let's turn our attention to the triangle OAB, this one here. We can find the area of a triangle by doing half times the base times the perpendicular height. So let's treat the line OA, the red one, the radius, as the base, and the blue line A to B as the height, since they make a 90-degree angle. So the area of this triangle is 1/2 times the base, which is 4, times the height, which is 4 tan 80. If you type this into your calculator, you'll get this number here. Now let's remove that triangle, and instead focus on this sector here. To find the area of a sector, we use the formula theta over 360 times pi r squared, where theta is the angle. So the angle is 80, so we'll start with 80 over 360, times by pi, and then times by the radius squared. The radius of that circle is 4, so times by 4 squared. Stick all of that into your calculator, and it will give you this number here. So to find this shaded area, we'll do the area of the triangle, subtract the area of the sector, and that gives you this answer here, rounded to 1 decimal place like it asked for in the question. For the first part of this question, we're told that Ian says, if x is greater than y, then sine of x must be greater than sine of y. And we need to use an example to show that Ian is not always correct. Now there's loads and loads of possible examples for this. In fact, infinitely many possible examples. So you'll just need to check that your one works in the same way that mine does here. So I'm going to pick two numbers, and I'm going to make sure that x is bigger than y. So I'm going to make x equal to 100 and y equal to 90. So if I do sine of x, sine of 100 is this number here, 0.9848. And if I do sine of 90, I actually get 1. So we've picked some numbers where x is bigger than y, 100 is bigger than 90, but when I did sine of x, it's actually smaller than sine of y, since 0.9848 is smaller than 1. So as long as the two numbers you select show something similar to this, you'll be okay. Now on to the second part of the question, we're going to find the upper and lower bound for the area of this triangle. Let's start by finding the bounds for all of the numbers in the question. So let's start with a, which has been rounded to two significant figures. The lower bound for that will be 6.25 and the upper bound 6.35. And then for b, lower bound 9.15, upper bound 9.25. And on to c. So this one's been rounded to two significant figures, so you need to be careful. The lower bound is 125 and the upper bound is 135. Now I'd encourage you to write those down because they'll get you some marks even if you did the next bit wrong. So now we need to find the area of this triangle. You'd use the formula area equals 1/2 times a times b times sine c. So we need to put in some numbers here to try and make this as small as possible and as large as possible. So let's start with the lower bound. We'll do the area equals 1/2 times the lower bound of a, since we want that to be small, so 6.25, times the lower bound of b, since we want that to be small, so 9.15. Now you need to be really careful with this next bit. Intuition would tell you probably want to use the lower bound of c at 125 and do sine of 125, but you actually don't. So the first part of this question was trying to give you a clue. If you do sine of 125, it's actually bigger than sine of 135, so you don't want that one. You actually want the smallest one possible, which is sine of 135. If you type all of this into your calculator and then round it to four significant figures, you get 20.22. Now we move on to the upper bound. So we want the largest values this time, so 0.5 times the upper bound of a, 6.35, times the upper bound of b, so 9.25, and then the largest value we can get from doing sine of c, so this time it's actually doing sine of the smallest number, 125, so times sine of 125. Type all of that in and round it to four significant figures, and you'll get 24.06. So the upper bound 24.06 and the lower bound 20.22. For this final question, we've got some simultaneous equations and we need to find the one point of intersection that they have. So what we're going to do here is take the second equation, where it says y equals 6 over x minus 1, and replace that with the y in the first equation. So we're going to write out the first equation again, but whenever we get to a y, we're going to write 6 over x minus 1. So the first equation is 3 times by y, which is now 6 over x minus 1, plus 8x equals 32. So we've now eliminated the y, we have an equation in x that we can solve. So let's now focus on this part here. We've just got 3 times this fraction, so you can just times 3 by the numerator, which is 18, so you get 18 over x minus 1, and then plus 8x equals 32. Now we're going to multiply both sides here by x minus 1. So if you multiply by x minus 1 on the left-hand side, that'll cancel the x minus 1 on the bottom of that fraction, leaving you with just 18. But then you also need to multiply the 8x by x minus 1. And then on the right-hand side, we'll also times it by x minus 1, so 32 lots of x minus 1. Now we can do a bit of multiplying out here, so we've got 18, we do 8x times x, which is 8x squared, 8x times negative 1, negative 8x, and then on the right-hand side, 32 times x minus 1 will give you 32x minus 32. Let's take that up here and continue. So it makes sense now to get all of the terms on one side, probably the left-hand side, since we've got positive 8x squared there. So let's subtract 32x and add 32 to both sides. If we add 32 to the left-hand side, we'll get 18 plus 32, which is 50. The 8x squared isn't going to change, but then we've got negative 8x, subtract 32, which is negative 40x, equals 0. So we end up with this quadratic equation to solve. It's not in the usual format though, so let's rejig those terms a little bit. We normally have the constant one at the end here, and we can actually divide through by a common factor. You'll notice that 2 goes into all of these terms. So if we divide both sides by 2, on the left, 8x squared divided by 2 is 4x squared, negative 40x divided by 2 is negative 20, and 50 divided by 2 is 25. And of course, 0 divided by 2 is still 0. Now we need to solve this equation, so you've got different choices here. You could try and factorise, use the formula, or possibly complete the square. As long as you get the right answer, it doesn't really matter, but I'd suggest factorising this one. There's a bit of a clue in the question that it says there's only one point of intersection. This tells us that if we can factorise it, both of the brackets will give us the same number. So, looking at the terms here, I've got 4x squared at the start, so I suspect each bracket is going to begin with 2x, and looking at the 25 at the end, I bet they're both going to have a 5. So it turns out quite quickly you can spot that this is 2x minus 5, and 2x minus 5 equals 0. If you set 2x minus 5 equal to 0, you'll get x equals 2.5. So that's the only value for x. We also need the coordinates here, so we need to work out y. So let's go back to that original equation, y equals 6 over x minus 1, and just substitute in this value of 2.5. So we've got y equals 6 over 2.5 minus 1, 2.5 minus 1 is 1.5, and 6 divided by 1.5 is 4. So we end up with the solution here, 2.5, 4. Thank you for watching this video, I hope you found it useful. Here are some suggested grade boundaries. I wouldn't read too much into them, no one really knows the grade boundaries until after the papers are done, but it will give you a rough idea. Check out the video I think you should watch next and subscribe so you don't miss out on future videos.